Hello, welcome. In this short video, let us look at an example illustrating how to calculate the joint probability mass function from a given marginal probability mass function and conditional probability mass functions. We will also look at the calculation of covariance function between the two random variables from the constructed joint probability mass function. So given the marginal probability mass function PA of A is equal to 1 by 3 for A equal to -1 and 2 by 3 for A equal to +1 and 0 elsewhere. And we also have the conditional probability mass function, that is probability of B given A at A equal to -1 is equal to 1 by 3 for B equal to 0 and 2 by 3 for B equal to 1 and 0 elsewhere. And the conditional probability mass function at A equal to 1 is equal to 1 by 2 for B equal to 0, 1 by 2 for B equal to 1 and 0 elsewhere. So given these definitions, that is the marginal probability mass function of A and conditional probability mass function of B given A, we want to calculate the following functions, that is the joint probability mass function of A and B, that is P of A comma B, and also covariance of A comma B. So by definition, the joint probability mass function PA comma B of A comma B is equal to the product of B given A, the conditional probability mass function B given A at A equal to small a, multiplied by the marginal probability mass function of A, that is P of A. So by using this definition of the joint probability mass function on the given table, on the given definitions of the marginal probability and conditional probabilities, we can calculate we have the product P, B given A, or B at a value of A, that is the conditional probability mass function, multiplied by the marginal probability mass function. So we have the following table. That is, from the definition of marginal and conditional probabilities given, we can easily recognize that the range of values of A and B are -1, +1 for A, and 0 and 1 for B. So for A equal to -1 and B equal to 0, the joint probability mass function should be equal to, that is for probability of A equal to -1, B equal to 0. So this joint probability should be equal to the product of the conditional probability, that is B equal to 0 given A equal to -1 multiplied by probability of A equal to -1. So from the definition of conditional probability, this is the probability of B equal to 0 at A equal to -1 is 1 by 3 and probability of A equal to -1 is 1 by 3. So the product is 1 by 9. So the first value in the table is 1 by 9. The first value in the table is 1 by 9. And similarly, the second value, that is P of A equal to -1, B equal to 1, is the product of the conditional probability at B equal to 1 given A equal to -1 and probability of A equal to -1, which is from the definitions 2 by 3 times 1 by 3, which is 2 by 9. Similarly, the other two probabilities can be calculated as 1 by 3 times 1 by 3. So this is the probability of joint probability of A and B. Next, we want to calculate the covariance function of the random variables A and B, that is covariance of A comma B, which is by definition equal to expectation of AB, that is the correlation function, minus the product of expectations of A and B. So by definition, expectation of AB is equal to the summation over all values of A and B of the product A times B into the joint probability mass function, which is from the table, that is from A equal to -1, B equal to 0, the product is 0, and for A equal to 1 and B equal to 0, the product is 0. So only values left are A equal to -1, B equal to 1, and A equal to 1 and B equal to 1. That is these two probabilities, the values corresponding to these two probabilities. So the products are -1 and +1. The probabilities are 2 by 9 and 1 by 3. So this is -1, 2 by 9 plus 1 to 1 by 3. So the total is 1 by 9. Next we want to find the expectation of A. So by definition this is equal to the summation of the product of A with its marginal probability mass function. So instead of by using the given definition of the marginal probability mass function, that is this definition, we can easily calculate the expected value of A. That is, it is the sum of the product of A with its corresponding probability, sum of the values of A's with its corresponding probabilities. So it is -1 into 1 by 3 plus 1 into 2 by 3. That is -1 into 1 by 3 plus 1 into 2 by 3. So this is equal to 1 by 3. And similarly, expectation of B is equal to the summation of B times the marginal probability mass function of B. But we do not know the marginal probability mass function of B. Though it can be calculated from the joint probability, it is much easier to use the following definition for the expectation of B. That is, summation over all values of A and B of the product of B with the joint probability mass function. This is equal to, so for values of B equal to 0, the product of B and its corresponding probabilities will be still 0. So for the value of 1, that is for value of B equal to 1, the products are 1 times 2 by 9 and also 1 times 1 by 3. That is, we have 1 times, for A equal to -1, we have 2 by 9, plus for A equal to +1, we have 1 by 3, which is equal to 5 by 9. Therefore, covariance of A, B is equal to the difference between the correlation function and the product of these two expected values. That is 1 by 9 minus 1 by 3 into 5 by 9. This is equal to -2 by 27. Note that a covariance value can be negative. Thus, so in this example, we learned how to calculate the joint probability mass function from a given marginal and conditional probabilities, and we also learned how to calculate the covariance of two random variables from a derived joint probability mass function. Thanks for watching.